I'm Andy Starks. I couldn't possibly have remembered to say that had it not had the speaker notes there. So, I'm Andy Starks. I'm from, awesome. I need to move this forward too. Okay. Anyway, I'm from Matnica. We make SMPTE 2110 and IPMX IP and technology. And, Matnica generously donates my time to Ames, where I am the, marketing working group chair. And so that's what capacity I'm in here today. So I'm excited to talk about IPMX today and the roadmap, where we're going and, how we're going to get there. So a quick recap, Sam Racine, about an hour ago, gave us a great overview of IPMX and the market case behind it. And then Jed just finished up his talk about the technical architecture of IPMX and how it's structured and how it builds on SMPTE 2110. My job is to kind of bring it home, which means shifting focus from why do we need it and what is it to are we there yet, right? Or actually the roadmap. So Ames launched IPMX back in 2020, like literally in the shadow of COVID. We were like getting, tested or hands washed and everything as we were leaving ISE, which seems like about a million years ago or kind of yesterday, both at the same time. But since then, IPMX, we really made a lot of progress. We're about 80% done, and now we're kind of to that like second 80%. But actually, in reality, we're really on that final approach. We're now kind of in the final stretch of IPMX where we're getting into the documentation phase and those final details. I'm going to kind of walk through kind of the stretch between here and what we'll call the MVP. The next things that we have coming up here, first, we're introducing the roadmap here. At InfoComm, this year, we'll be, presenting the documents that make up IPMX. So that includes the technical documents that will be finished up at that point, plus the logo and compliance documents that we'll have. And then this summer, we'll have a testing event in August, and then we'll have our MVP launch in September. So this is where you're going to see the very first IPMX products kind of hit the market. And then post-launch, we'll have additional capabilities and profiles that'll come up there. And so I'm going to go into detail of these parts here as we go through the presentation. So what makes an IPMX device? So these are the key elements of how IPMX is structured from a product standpoint, right? So it's one thing to have, we can release a standard, right? And it's out and we have version 1.0. And then if we want to make a change to it, we do version 2.0. But that can be very confusing. It can be very limiting. So what we've done is we've broken the IPMX structure into different components. So we have the baseline requirements, and these are the core timing, discovery, behavioral rules. These are the things that every single IPMX device must support, right? This is different if you're used to SMPTE 2110. By convention, you have NMOS. By convention, you support, 1080p or whatever your resolutions are. Resolutions are something that we don't define, but in IPMX, a lot of those things are actually requirements. The next up, we have profiles. Now, profiles are the standardized way that content is exchanged, right? So we can think about this like codecs, but also that includes an uncompressed profile for audio and video, mezzanine codecs. Jed mentioned JPEG XS. There's also H.264 and 5. We'll talk about that in a little bit. But profiles are basically interoperability content points, right? So your device can support one or more profiles. And in fact, in IPMX, you can actually support profiles that are not part of the interoperability standard as well. So you can have a profile that would be maybe like a proprietary codec. IPMX allows that, but on the flip side, IPMX requires that your device supports at least one interoperable codec or interoperable profile, I should say. Part of profiles is something called profile modes, or these would be like a profile feature. This is, for example, JPEG XS has a technology called TDC, and it's time dilation compression or something like that. Basically, TDC is a technology that makes desktop content much more efficient in the codec. So if you're taking in desktop content and you're doing 4K 60 over a 1 gig connection, and you have JPEG XS TDC, it's going to work a lot better. Your device can support JPEG XS, and it also can support JPEG XS with TDC. It has to support JPEG XS, so if your sender is not doing TDC, it has to work. But if you optionally also support TDC, that would be a profile mode that's supported. H.264 and 5 would be a similar thing. So we're also gonna support low latency modes in there, 444. Those are different profiles that we'll test for with an IPMX. That would be also considered a profile mode. And again, you can support more profile modes, but we'll be defining certain key profile modes that are popular in the market that we'll test for interoperability. And then finally, we have capabilities. So these are optional features that must interoperate, and they typically work across all profiles. So let's say you have a device that supports uncompressed video and JPEG XS or H.264, and you support HDCP content protection. In that case, typically you would expect HDCP works across all of those profiles. That's why we call that a capability, right? You can, maybe your device has some limitation that it doesn't work in that way. That would be like an exception. That would be fine. But typically a capability is intended to work across all the content profiles your device supports. So what is actually in these neat little containers that we've come up with? This fantastic slide here is I'm going to basically just kind of talk through these. But one thing I'll mention ahead of time, if you're interested in learning more, just Google VSF TR10 and you're going to find every one of these documents in here. They're all available for download. So to start, we'll talk about the baseline profile. Uncompressed video, very, very similar to SMPTE 2110-20. The difference is that in IPMX, we require the device to support RGB 8-bit, as well as RGB or YUV 10-bit 422, like you do in broadcast, right? So, of course, 420 is fine, all of those other ones, but if you're going to be an IPMX device, you got to support RGB 8-bit and 422. Uncompressed audio, we have additional modes that, or additional profiles that we've defined here that they very much actually, Andreas I hope he's nowhere here because if I say something wrong, he'll jump all over me. But, things like 44.1 and 48 kilohertz 16-bit audio, these are not typical broadcast things that you would see. But in IPMX, we test for interoperability in those profiles because it's very popular in the Pro AV market. I already mentioned JPEG XS and TDC. That's part of TR10-11, very similar to the JPEG XS that you see, actually pretty much the same as what you see in the broadcast world. The only difference really is that we require you to support 444 YUV and RGB in JPEG XS. And then also H.264 and 5. Now here, the baseline requirement is 420 for both of them, for 264 and 5. And that's because a ton of cameras out there are all 420. And we want to be able to leverage that market. And so that profile, the baseline requirement is 420 with additional profile modes for low latency and 444 if you're using it for more traditional desktop content or for, normal operation. Moving on to capabilities here, there's really two main capabilities that are going to be part of the initial MVP. There's quite a few more capabilities that are on the roadmap and even ones that have got specifications written for them. But we want to make sure that everything is well tested and interoperable right out of the gate. So these are the two primary capabilities that we're starting with. First, we have HCAP and HDCP. And kind of HDCP, if you're in the Pro AV world, it always ruins the fun. But what we've done in IPMX is we've gone through the hard work of working with the DCP, making sure that our methods are approved by them legally and that it's a robust implementation. So HCAP is the protocol. It's called HDCP Key Exchange Protocol, and that's basically the way the keys are exchanged. And then the actual HDCP encryption is handled in the same way that any other device that has HDCP is handled. So that's part of IPMX. A related technology, and I'm really excited about this one, is privacy encryption protocol. Now, this is basically the same thing as HDCP, but for you, not the movie studio. So if you've got a secure environment where you need to encrypt the content, that's what privacy encryption protocol is. This protocol is super cool. There's a lot of neat features in it in terms of being able to do things like having secure communication between two devices that not even your IT administrator can snoop in on. It's got all of the different technologies in there that you would want and expect. But the cool little twist on it that I think is really neat is that the way we've done it is that it's very, very compatible or basically very, very friendly to the implementers that are also supporting HTCP. So they're done in a very similar way, and you're able to basically, if you support HTCP and PEP, you don't have to duplicate everything in your implementation. It leverages the same kind of structure. It makes it easy to implement. And then the baseline requirements. I know Jed kind of probably talked about this quite a bit here, and I'm just going to briefly recap it. We have the timing requirements. This is probably what is the biggest thing biggest difference between SMPTE 2110 and IPMX. So IPMX supports SMPTE 2110 style PTP, but the baseline requirements are a lot more relaxed because typically you're going to have compressed video, which allows you to kind of dial back the PTP requirements, making it easier to handle PTP on switches that are not PTP aware. The second thing, of course, as Jed mentioned, is that we also support no PTP operation. So in environments where you want to throw a couple of boxes down, you want to plug them in and just make them work, and you're not going to stand up a PTP service, IPMX will work in that environment, and that's part of the TR10 specification. Feel free to ask me questions about that later if you want. The next one is NMOS, which is funny because NMOS is from AMWA, and yet VSF is defining some NMOS things. But here, what TR10-8 does is it says you have to have ISO 4, you have to have ISO 5, and you have to have ISO 11. And some of the different options that are in NMOS are not optional in IPMX. So, for example, you have to support ad hoc discovery, again, where I'm not going to stand up a registry. I'm just going to want to see the devices like I would my printer. That's got to be supported on your device. You have to support MDNS. And you also have to support DNS-SD. So it's all three have to be in an IPMX device. And so it can behave like a installed system would behave, and it can also behave like an ad hoc system. And there's some other work we're doing there too that's pretty interesting. And then finally, if you're familiar with SMPTE 2110 and kind of its history, you know of the JTNM, and you know of the TR 1001-1 document, which kind of defined a lot of the behaviors and things that a good system should be. Very similar document as the TR9 document, or TR10-9 document for IPMX. So my device is streaming and I lose power and power comes back up. It should continue streaming again. That's an example of something that would be in the TR10-9 document. So you put all those things in your product, you get it all done. How do we know it actually works? And that's where interoperability testing comes into play. So right now we're actively developing the IPMX test plan. And in fact, just about 2 weeks ago, we finished our third interoperability, what's called a dirty hands event. Dirty hands events are where vendors come in with stuff they think works. And you come in, you make it in, you plug it in. And of course, there's always going to be a couple problems there. You can go back in and recode it, make it work again. And the purpose of those dirty hands events are really to test the standard. You know, those were the past prior to. We wrote it. You went back and implemented it, and I interpreted it this way, and maybe you interpreted it a different way, and you find all those little edges in the documents that you need to be ironed out. So that's what the purpose of a dirty hands event is. This last dirty hands event, we call it a plug test as well, but this last event was more to test the test plan as well as the early adopter products. So we're testing the products, but we're also testing our test plan to make sure that everything in there is covering everything that needs to be covered for interoperability. Now in August, I mentioned that in the slide 2 that we have an event coming up in August. That will be what's called a clean hands event. In a clean hands event, you come with your product, you can't touch anything except for configuration, and either it passes or it fails. And that's where we're actually going to have IPMX products, validated and certified, right? Now, the JTNM tested process has brought us SMPTE 2110 that we know and love today, and so it's been extremely successful. The challenge for IPMX is that we're really addressing a much, much bigger market. It's estimated that the Pro AV market is about 10 times the size of the broadcast market. So we can't expect manufacturers from all the world to come to our facility, to come to a facility, hosted by Evertz. This last time, the NFL hosted the one prior to that. It's just not practical. So part of our work is to stand up independent testing and also some form of self-testing as well. So Self-testing is useful not only to pre-validate your device before you actually send it out for certification, but we also anticipate wanting to be able to support smaller developers, software developers, open source developers. There's probably a different logo requirement there or labeling that will be involved there, but that's all part of kind of the roadmap of testing. That's, things that we're working on. So this kind of harkens back to the prior slide, but between now and then, what are we actually delivering? What are the artifacts that we're going to put out? So at InfoComm, we anticipating having all of those TR10 documents that I mentioned earlier complete, which most of them are in final form. There's a couple of them that are not, that we're still reviewing. Nothing show-stopping at all, but just the little details. And also too, there's the sort of more administrative documents, like I'm new, I don't do IPMX, I want to make an IPMX device. How do I actually get my logo on here? What do I need to do? Who do I call? That sort of thing. So those documents we anticipate having completed by June. And then at around that same time, we want to have the IPMX test plan finalized as well. And I mentioned the self-testing tools. I don't know that we're going to have those released at that point, but that's, part of our roadmap here. And then that Clean Hands events in August with the IPMX launch in September. So that's the MVP, but it's also just the beginning. After launch, we already have a clear path for expanding the specification. I mentioned the profiles earlier. There's also additional codecs that we're evaluating for different purposes. There's a lot of capabilities that I didn't mention. So things like FBC or forward error correction, that's right. And then USB interoperability. If you guys are familiar with the Pro AV industry at all, you know of KVM, which is keyboard video mouse. I'm watching the video and I'm controlling the computer that I'm watching over the IP network. That's KVM. If you don't have KVM and AV over IP, you're not getting anywhere. And so we've actually defined the USB interoperability extension already in VSF. There's already a couple manufacturers that have implemented it. We're not launching that at the MVP because we want to make sure we've got the testing done and we don't want that to delay us. We also are going to focus on scaling the testing infrastructure that I mentioned earlier. That's those self-test, standing up independent certification labs. And we're going to continue to do the work, just as we SMPTE 2022 came from VSF, so did SMPTE 2110, and now we're doing IPMX. And after IPMX, we're going to keep going as the industry grows and moves. We're going to keep evolving IPMX as it goes, taking advantage of that structure that allows us to make those changes and make those additions to it without disrupting the existing products that are out there in the field. So as the bottom of the slide says, then IPMX MVP is just the beginning, not the end, of course. So I just want to end by saying, why does this matter to any of us, really, right? So if you're a manufacturer, especially if you do any work in the Pro AV space, you know the pain of fragmentation. You know what it's like to have a market filled with different protocols for something as basic as moving video around on a network, right? Also, you know what it's like to have to support a separate live production system versus your AV over IP system where you're putting that in conference rooms and digital signage and things like that. Different requirements, right? Different extra features on there, but basically they're doing the same thing. They're moving video and audio. Fortunately, today, those are entirely different systems with different control plane protocols and different network requirements that makes it a big pain. Having something that works with SMPTE 2110 that also works in Pro AV is a huge advantage. Actually, this is something that really we evolved in our thinking. When we started, nobody wanted to hear about SMPTE 2110. They were like, no, we don't want that in Pro AV. Uncompressed, PTP, all that stuff. But then as we started to make IPMX a lot more flexible and a lot more accessible and a lot easier to implement in software and things like that, they saw the advantages of it. And then they started to really appreciate that they actually, there's a lot of companies out there, corporations, that schools, college campuses have a lot of SMPTE 2110 gear. And the fact that they're able now to have a single system that works across live production and presentation workflows is just, one of the key things that really drives demand for IPMX. For integrators, less complexity means more opportunity for you guys. It means less messing around with the details of transport and more creative action, right? Having an open protocol that is based on HTTP and JSON is much easier for an integrator to do innovative things without having to go to a vendor and trying to find a product and buying something that's $20,000 to do like $100 thing, right? There's a lot of those little use cases out there that can be solved with a Python script. IPMX with NMOS gives you that kind of flexibility and that kind of power as an integrator. And for really all of us, transporting content, video, audio, that's how we communicate. It's the most popular form of communication today, right? And having it as an open standard, I think, is a really important feature of what we're doing. So what's next? If you want to learn more, please visit us at IPMX.io. That's the QR code on the screen there. Visit us in behind here at the IP Showcase. And also, too, I want to hold this up. This is that little training card. Tomorrow from 10 to 2, I believe. I should know that off the top of my head. But we have training sessions that are going to go much more deep dive. There's a couple of them that I'm really excited for. The Jack did the testing event. He'll have a report on that. He'll tell you what happened, what they found, that kind of thing. The other one I'm kind of excited, and there's other ones too, and I'm short selling, the ones on NMOS and everything else. Those are really awesome ones too. But I know Jean Lapierre is going to end it with setting up an IPMX system, or how to build an IPMX system. So I'm very excited about that one too. And then, of course, reach out to AIMS, VSF, and AMWA. These are the three organizations that are really making IPMX happen. AIMS is the marketing side of things. VSF does transport and is really defining the core documents for IPMX. And, of course, AMWA makes the control plane protocol, which is how everybody interacts with it and how we actually make it work, right? So those three organizations are all very active, very involved in it, and we would welcome your participation or even just your feedback. So maybe you don't want to, get on the calls or whatever, but it's your telling us what problems you need solved, that kind of thing that really drives IPMX's roadmap. So with that, let's build IPMX together. And if you guys have any questions, I'd be, am I done already? Oh, I'm at 0. Man, I went over. Wow. Okay. Well, no questions. None. No, you can just grab me after and I'd be happy to talk. So thanks.